Hello. Thank you everyone for being here tonight. First things first, whenever you do chemistry, gotta be safe. So first things first is I'm going to put on gloves and goggles. There is nothing tonight that you have to worry about, but there is something that I do need you to worry about, and that's to enjoy what you see. That's the only thing that you need to worry about. Now, a lot of people that have come today have talked about pressure. In science, we define pressure a little differently. That's force per unit area, for those who don't know about that. But I also saw some quotes today about Einstein, and so I wanted to tell you a little bit about pressure and Einstein. I don't know if you know this, but Newton, Einstein, and Pascal were playing hide-and-go-seek one day. And so Einstein is it. And since time is relative to Einstein, it goes really fast when he counts, right? It's like 1, 2, 100. And so Pascal goes and hides real fast. Newton, he's a little slow on the things, because he's derivative, right? So he has to worry about things like that. So he starts thinking, and all of a sudden, Einstein gets to 100, and right before, Newton draws a square around him. And he says, Einstein turns around to Newton and says, "Newton, I found you. You're it." And he goes, "No, you found 1 Newton over 1 square meter. You found Pascal." So, all right. So with that, we'll start the bidding at 5. No, just kidding. The first thing we're going to do. The second thing I want to say is, some of these you can try at home. Do not try them at home. That's a disclaimer I put on everything. All right. So first thing we're going to do is show how many ions are in a pickle by basically lighting it up. Okay. So everybody knows how a light bulb works, right? There's a filament in the middle of it. That filament gets very hot. Gets so hot that it starts to glow and gives off light. Well, we're going to do the same thing with a pickle, except we don't have the filament, right? But the pickle has ions in it that will conduct electricity. And so what we'll do is we'll just take a regular cord here and just 2 ends of a regular. Oh, we're shooting juice everywhere here. All right. And then I'm going to go ahead and use a different pair of gloves because now I've got juices everywhere. All right. And we'll go ahead and just, can you turn the lights down, please? All right. Turn this off too. Turn everything down if you can. All right, as it starts conduct, yeah, there you go. It starts conducting, and it'll start lighting up. Lighting up, there you go. And as the electricity's flowing, it will flow from one side to another, and then eventually it'll get so hot it will cook, so I am going to turn it off. Uh-oh. All right. 1 down, 2 to go. No, just all right. So the next thing we're going to do is elephants are pretty big, right? They got really big tusk. So what we're going to do is we're going to make their toothpaste. This reaction involves whatever happens in everyday life can always be juiced up by what is called a catalyst. And in chemistry, a catalyst is a specific thing to speed up a reaction. It lowers activation energy. And so what happens in everyday life for hydrogen peroxide, this is just hydrogen peroxide, is that it will eventually turn to water. It'll just let out the oxygen and hydrogen accordingly, and it'll turn to water. But what if we had something to speed that up? Well, that's a catalyst. So what we're going to do And everybody in this room can be a catalyst in their own specific way. So what we're going to do is we're going to show how this releasing of effectively different gases with some dish soap. And what color do you want to brush these elephants' tusk with? Red? Red sounds good. All right. Since it's TED Talk, right? All right, we'll put some red in there. All right, and then all it takes to affect a little bit of change is a little bit of catalyst. And it will continue to grow and continue to grow and go all the way out the graduated cylinder there. That's why it's in the bucket. All right. So, as that's going on, the other thing is I want to talk to you about, since we're on the subject of energy, I want to talk to you a little bit about the idea of gas in our cars. So, what's safer, a full tank of gas or a half a tank of gas? Full tank's safer. Why is that? Because it's not. It's a gas. There's no room for the gas to the gasoline to volatilize. And so all I've done here is taken a little bit of isopropyl alcohol and I have put it in a situation where now it's all fumed up. So the reaction of a combustion reaction is just when a hydrocarbon and oxygen come together with some heat. They make carbon dioxide and water, right? Okay, so we're going to do that, but we're going to do it at room temperature. I want you to notice how fast this reaction will go. And notice, there's the water. All right? Now what do we do if we cool it off? This has been sitting in ice all day. Sorry. Whoops. We'll do this right here. Sorry, Rachel. So here's my alcohol. We're going to do the same thing. Put a little alcohol in it. So this is effectively changing the amount of energy. So in that reaction, we lowered the activation energy with a catalyst. What we're doing in this reaction is actually lowering the available energy around us, available to the reaction, which means it still has trouble getting over the hump. So what will happen is we'll have the fire still, but the fire will grow as the bottle heats up. So yeah, turn the lights down a little bit. And all I did was change the temperature. There's the water. All right, last thing. So, how many of you like going to the movies? I like going to the movies. So, how much energy do you think is in a little bitty dot candy? It's good for the waistline, as you can tell. So, well, the answer is a lot. But our bodies are really good at taking in energy and using it for things. So, we can eat a whole bucket of these things and not necessarily see a huge change in our waistline. But what if we turn that energy into light and heat? What would that look like? Well, it would look something like eliciting a reaction. All right, so the way we do that is we increase the surface area of a chemical I have in here called potassium chlorate. The way we increase the surface area is we turn it from a solid to a liquid by, of course, using a blowtorch. Almost done. All right, now we're all liquefied. All right, so what I'd like you to do when I say go is turn down all the lights if possible, and it will take off. All right, so remember, it's just a little bitty candy. How much energy is in that little bitty candy? Turn out the lights. Think about how awesome our bodies are as you watch this thing give off light, smoke, all kinds of other good stuff. And that's going to be it. Thank you for coming to my TED demo, I guess. So.